Electronics. I am Dr. Leo Joseph, and I am going to teach you about what is mean by digital electronics and something different from the different perspectives and different applications we will discuss. And before that, I would like to welcome you all in this manner. That is, my theme is don't read the subject as a quantitative, read it as a qualitative. That is, deep learning is very important in this scenario. So I request all the students or the followers who are taking this course, use this strategy in different courses and know the theme of the course, what you are learning. That is very, very important in this aspect, since most of the students or learners don't know why they are studying this course. Without knowing something, some staffs are telling write 0, write 1 means it is take it as granted. In that manner, don't study any subject. Take it in a deep learning manner, and you have to explore why you are studying this subject and where we can use that applications in our either in your projects or in your lifelong learning strategies. Like that, you have to use that as a thing. So here what I am trying to say is, first we are going to see what is the meaning of this digital electronics subject, and we will discuss about something new what we are going to see. Okay, so okay, so this can be done. Fine. So now I am going to take into the walkthrough of the subject called digital electronics. Hope it is visible to everyone. So before going into this subject, I am going to tell you about what are all the things to be done before studying this course. So I will move this. Hope it will better. So first, digital electronics means first you don't think this is something irrelevant, since first we need to learn what is meant by a signal. So signal is nothing but a representation of physical quantity. That is the very important. After that, I no need to tell, since this is not. After that, several meanings are there, but I want to highlight only representation of any physical quantity is called as a signal. So if I want to tell something to the user which they cannot see by their own, for example, electricity. We are studying so many things about electricity, but really we don't see, no one can see a current. We are telling that this current is coming through this wire, or power is coming through this wire, but no one till now know how electricity, what is its color, anything. So what we are doing is we are using some analyzers like CRO or spectrum analyzer to understand how a signal will look like. We are assuming that signal will be like this. This is called sine wave, and we are calling it as alternating signal, that is AC. What we are calling it as AC, and flat signal is called as DC in terms of electrical, electronics, whatever the measurement area it will be. So here plus and minus, you are taking it as positive half cycle, negative half cycle, representation. This is what I am trying to tell. This is called representing a signal. Here in analog signal, we are representing this in the form of a graph. Okay, since these signals are continuously varying with respect to time. Each and every instant, this signal seems varying continuously. If I want to take one signal here to the next instant of time, the signal seems either increased or decreased. So if I am measuring 2 and after that I am measuring 2.1, means this is too many huge variations. Since in between this you may have the 2.01 or 2.001 or 2.0001. This depends on the application of where the signal is used. It may be used in very minute microscopic process, means you have to take very minute values into consideration. Whereas when we are doing for some other practices like general analysis, means at that case we will take some light variation that depends on the scientist application, observer, and everything. But whereas when we are representing a number, we want to represent anything for design aspect. So in terms of design, I am asking about two things are there. One is called analysis and another one is called design. These two things you have to keep it in mind. So for analyzing anything, any circuit behavior analysis, then I have to definitely go for a concept called analog signals. So you need to take everything, behavior, characteristics, everything in a very micro level, means then you have to go for analog signal study. That's why the subject is divided into two categories. One is called analog electronics and another one is called digital electronics. If I want to go into design aspect, so I want to design a circuit, means then micro level analysis is not necessary. I want to make it in the form of simple understandable manner, how the circuit work if the signal is low in level and how it work if it is in high level. That is sufficient for me for any design. So in that aspect only our hero come into picture, that is called digital signals. So in the digital signal practice, the same graph we will draw, but how we will draw, let us think. You can compare these two signals. So here I am drawing the same graph by taking time and temperature. So I consider this also time and temperature, okay, for simplicity. At zero level, the signal is, for example, the temperature remains high. Then I can put simply as 1. At the one instant, the signal is temperature is low. Then I can put it as 0. So on seeing this, at 0 degrees Celsius or 0 seconds, the temperature remains high. And 1 second, the temperature remains low. That information required for me for designing any circuit. I don't want any that thermal effects, heat sinks. These things I don't require for designing any circuit. So this is for used for analyzing the circuit, analyzing the behavior of the components of the circuit elements. So for studying the operational factors of a particular circuit, I need only representation of the circuit parameters. That is, the circuit parameters are represented in the form of digits, either in the form of 0 or 1. So there the thing come digital electronics. So with that we can able to analyze any circuit. So that is represented in the form of digits. You can understand, represented in the form of digits. So in practice, digits we can call it as what? Numbers. So for studying the digital electronics, which is necessary, numbers are the most backbone of this subject. That's why the first topic in any digital electronic circuit is number system. There are so many number system available in practice, but for simplicity, I am taking 4 different number system into consideration. One is called binary, second one is called decimal, third one is called octal, fourth one is called hexadecimal. Out of this, there are so many number system in practice, but considering the importance of the subject, I am taking only these 4 number system for discussion. Now, what is mean by a binary number system? Why I am taking binary number system means today world is completely digitized. So without computers, nothing will be there. Without mobile phones, nothing seem operational. So inside your computing devices, it may be either laptops or mobile phones, there is a small chip. This is where electronics industry is revealing. Out of outer hardwares are just for as per our design we can change. Nowadays keyboards are coming handy, touch wireless keyboards, every design, everything they are changing, but only one thing is unchanged, that is called processors. High level processors coming, higher end processor coming, dual core processor coming, everything coming, but ultimately map of the processors is not changing. Even at the time of computational computer invention, they used one map, skeletal map. That map inside that components can understand, it is developed in such a way that component can understand only two elements. One is 0 and 1. 0 means low level signal and 1 means high level signal. Till now, all circuits are following these strategies. For example, we are taking a pulse called clock pulse. Later you will see in this subject, high level clock pulse, low level clock pulse. Finish. 0 and 1. Simple concept. So everything signal is coming there means the representation is flag will be triggered 1, and the signal is not coming means we will represent as 0. We will get only two fellows. One is either 0 or 1. 0 coming means signal is coming. So what is the simple representation for fun basis? I am telling, inside a tank, water is there, outside one pipe is there. Water comes means 1. Water is not coming means 0. Simple. Yes, a computer can analyze this in a very quick and fast manner. That's why, even though now 2024, this era, everything is fastly changing. Apple computers, everything are coming into practice, but this map of the processors is not changed from one number system to another number system. Even you can design the processor based on octal or hexadecimal or decimal. Anything is possible, but you need to change the internal skeleton, which become more and more complicated. That is unnecessary also. Since already one efficient system is working, we have to use that system as a base, and you have to develop modernized system over. That is a good practice for a good engineer. No, I have to disrupt the entire system. I want to build decimal system, decimal based numbers. I want to use this for my understanding. I have to be unique means then the smartness of the work is totally not. This is not a feasible way of engineering solution. Since one system is very perfect means using that base, we have to develop some advanced system. So in that manner, today scientists also relying on the ease of understanding and user friendliness and design complexity. Mainly, we are totally focusing on efficient and economic system, economic power saving system. This is the main aim. All are businessmen. We want efficient system. It should be low budget, power saving. If three things are satisfied means no, ultimately my purpose is solved. If I design decimal system means then what happened that the system design get complicated. System design get complicated means automatically economy of the design practice will increase, and power saving also not possible, since if you increase the parameter means power consumption will also increase. So instead of going in microwatt, I have to use watts, and so that my economic conditions, so efficiency is same, but these two parameters are not matching means then why to develop that system? Instead of that, if the same efficiency with less power and more economy is available means then that is a better way to use with that system, go with that system. So based on several what we called state of art procedures, we are coming into final conclusion, better to use simpler design with much efficient economic and power saving practices, and finally conclude that don't touch the skeleton of any computational system, let them follow zeros and ones, so it will be easy for our design as well as computational process. That's why we are using everywhere this binary number system in practice. This is very simple and quite understandable and everything. So what is mean by this binary number? Binary number are very, very simple. You can easily understand. Under binary number system, we are having only two members. One is 0 and another one is 1. Very simple family. Okay, only two members are available, either him or him. So if I want to represent any number means I have to always use a base number. That is very, very important. For example, if I am using 125 to the base 10, that means this is called base. This base is nothing but this indicates this number belongs to which number system. So usually in our practice there are 4 number systems available. One is called decimal number system, that can be possible by combining 0 to 9 range numbers. So here also you can check here, 1 belongs to this category, 2 belongs to this category, 5 belongs to this number. So this automatically, this number system, its base is 10. So I am calling it as decimal number system. But there is no hardened rule, but that this number should be compulsorily a decimal number. Since anyone follows this base 16 means automatically this number will be called as hexadecimal number. But who decide this means it depends on the user and application. So based on the application, if I want to use it as 125 to the base 16, you can use, or if you want to use it as 125 to the base 10 means you can use. So this is the base where the number systems feels important. One tricky question I will ask now. 1010 base 2. So if I represent this base, you can call it as a binary number. Okay, no problem. Without representation, can you tell this belongs to which number? If I ask this question means, usually if I write 1010 means everyone automatically write it is a binary without analyzing anything. But you need to look into a most important thing called base. Without base, a number cannot be mentioned as binary compulsorily. If you mention means the answer will be false. Since sometime it may also mention as 16. Then this system will become hexadecimal. Sir, you are telling wrong. 1010 means binary na. How you are telling it as hexadecimal means yes, you are correct. But the 1010 base 2 is called binary. How I am reading, you listen my words. 1010, that like that I am reading 1010, only I am using two terms 1010, then it is a binary number. If I am reading it as 1010, then that become hexadecimal. So the way how I read this number also very important. 1010 to the base 16 means hexadecimal, 1010 to the base 2 means the binary. So if I read 1010 as hexadecimal means that is false. So there the trick will be important. So one interview question they asked, what is the 1010 belongs to which family? Binary number, octal number, hexadecimal number, user specific. Like that one question is asked. Usually everyone will, what they will do, this is user specific is nothing but all of the above or none of the above, like that it is. But they have mentioned a standard company, they mention as user specific. So all most of the students are put binary. So answer is wrong since it is a user specific. Since 1010 may be octal or hexadecimal or anything, but here I am not mentioning any base. So without base, you cannot justify this number will belongs to this number system. So there you have to be very, very careful. Okay. So apart from this, so here I will write something. Decimal means it is formed by the group of 0 to 9, that is group of 9 numbers, and binary means it is a combination of number formation between 0 and 1 using the 0 members 0 and 1, and octal means it is a group of numbers 0 to 7 that comprises to form octal number system, and hexadecimal number means you can able to form from 0 to 15. With this group of numbers, I can able to form a hexadecimal to decimal number system. Whatever you want, you can take. Now, I am going to take a special case, hexadecimal number system. This is the most important thing. When you want to study the characteristics of a microprocessor only, then you have to take the consideration of hexadecimal, since it is represented in the form of alphanumeric codes. This is very, very important. Alphanumeric codes. alphabets also come into picture. Why alphabets are coming, let us check, so that we will think over while doing the conversion process. Okay, so that I will deal separately. Okay, as of now, no point of consideration. So apart from this, we are having some codes also, that is BCD code. BCD stands for binary coded decimal. Binary coded decimal, these are the codes. And a 8421 code, and 2421 code, and also special case gray code. All these codes are used for encryption practices, big data analytics, studies that involve watermarking, encryption, everything are coming into practice now. So if I want to watermark some important contents or encrypt some important texts, or I want to manipulate some important confidential matter from one form to another form, then automatically what I have to do, I need to follow some encryption technique. And beside that, there are so many algorithms available, like AES algorithm, so many Lorentz algorithm, like that. So many algorithms are available, but base for all this is codings. We have to use some codings to convert from one form to another form. So that we will discuss whenever we are going deep into that topic. As of now, you remember there are three coding techniques available in digital electronics. One is called binary coded decimal, and another one is called 8421 coding, and another one is called as 2421 coding and gray coding, that we will see. And now what I am going to say is, let us think the conversion process. Now I want to convert this conversion system. Why I want to convert means, sir, in the usual world, everything is in the form of human level understanding. So that is, usually I will write 125 means it is a decimal number. But when it goes into a system means, this system don't understand this 125, since internal map is mapped only to understand 0 and 1. It can understand 1, but 2 is not understandable, 5 is not understandable. Then this system will blink. So what I can do, I don't know anything. It can recognize only 1, and it will do the process, start doing the process. So what we have to do, first we need to convert this 125 into 0 to 1 level. So for that only we are studying this conversion system. Usually there are 4 conversion system depending on different application. We are having octal, hexadecimal conversion also, but in digital electronics we are mainly concentrating to convert any number to binary number. That is our main aim. Why we are studying this 4 system means, decimal to binary, octal to binary, hexadecimal to binary. If you know these concepts very well means, digital electronics is big not a big and it is very easy to understand, since you know how to convert every system into computational practices. So first, 125 to the base 10, as per my analogy, it is a decimal number. So why I have written this, defaultly it is a decimal number, also I represented particularly 10, so it is a decimal number. After that, what you have to do, I need to how to convert this. So question is, convert this 125 to the base 10 to binary number, to binary number. So 125 I am taking. So what I have to do, I need to divide by 2. Always keep it in mind, when a decimal number to be converted into a binary number, I have to divide it by 2. This group of family 10, that means 2, I have to divide this original number. Always take decimal to binary means division. Same case, binary to decimal reverse conversion means you have to multiply. This thing if you understand means, then nothing will confuse. Most of the students got confused here. Decimal to binary means we have to multiply or divide. So don't study the subject in the form of memorizing manner. So 125 to the base 2, if you memorize this means, then in the exam you will not able to clear. Whereas if you keep this strategy, decimal to any number, for example, here I will give you the strategy. So decimal to binary, decimal to octal, decimal to hexadecimal. Source is decimal. You are going to convert either to binary, octal, or hexadecimal depending on our application. So if I want to convert decimal number to binary number, what you have to do? Divide by 2. Decimal to octal means automatically divide will come. Octal means 8. Here you need to convert into divide by 16. Similarly, reverse conversion means just put. I will tell here binary to decimal, octal to decimal, hexadecimal to decimal. Everything reverse conversion means you have to multiply that with that number. Binary number should be multiplied by 2. Octal number should be multiplied by 2. Hexadecimal number will be multiplied by, octal number will be multiplied by 8. Hexadecimal number will be multiplied by 16. Then you will get the original number. So here I am going to take a simple example and I will tell you straight conversion and reverse conversion. So if I divide it by 2 means what happened? 6 2s are 12, 2 2s are 4, balance 1. And then again I am dividing by 2 means 31 to the base 0. Okay, and then dividing by 2 means 15, balance 1. And then 2 means 7 2s are 14, balance 1. And 3 2s are 6, balance 1. 1 2 is 2, balance 1. These things already I think for any level they can understand. If I write from, some scribbling in hands coming. So if I write from bottom to top, I will get answer as 1 1 1 1. Carefully write 1 2 3 4 5. So 5 1 0 1 base 2. That is important. All are writing the answers and they are not writing the base. So you have to write the base. So then only it will be 1 lakh something or 111101. It will be understandable. So this is the thing. So if I want to reverse conversion means what I have to do? This is nothing but binary to decimal. This is nothing but binary to decimal. This is very simple exercise. Anyone can do, even school students, any for kids can do, since it is very simple, right? So 1 1 1 1 1 0 1. So first take this number from left to right. That is important. So first 1 into 2 to the power 0. Already I told reverse means you have to multiply by 2, but in the powers of powers. Then 0 into 2 to the power 1. Okay, understandable. Raise the powers only. 1 into 2 square, and then 1 into 2 cube, and then 1 into 2 to the power 4. Okay, and then 1 into 2 to the power 5, and finally 1 into 2 to the power 6. These are the things to be done. Okay, everything covered. So 1 into 2 power 0 is nothing but 2 power anything power 0 is 1. So 1 into 1 is 1. This will be 0. This will be 4. This will be 8. This will be 16. And then this will be 32. And this will be 64. If I add, what I will get? 4, 2, 6, 6, 12, 8, 20, 24. 24 plus 1, 25. Okay, so 5, balance 2, 6 plus 3, 9 plus 1, 10, 10 plus 2, 12. I get the original number, 120. Like to convert a number and decimal number back to binary and verify you are getting or not. Similarly, for practice, you can take to the base 10, you can convert that into binary, and that answer you convert back to decimal, and you have to verify. For understanding purpose, once again I will take a walkthrough. I am not telling anything, just I am writing and explaining. I think you are understanding. 7 2s are 14, balance 1. 3 2s are 6, balance 1. 2 2s are 4, sorry, so it is wrong now. 2 means 1 2 is to balance 1, right? 2 is to 3 2s are 6 balance 1, 1 2 is to balance 1. So I can write 1 1 1 1 to the base 2. If I want to convert, reverse conversion means what I have to do? 1 1 1 1 1 into 2 power 0, 1 into 2 power 1, 1 into 2 power 2, and 1 into 2 power 3. Okay, very simple. So you have to write this as 2, this as 2, this is 1, right? This is 1, sorry, I have to erase this one. Sorry. Okay, so now I will write here. So this is 1, this is 2, this is 4, and this is 8. So what is the final answer? 12 to 14, 15. So I will get 15 to the base 10. See here, base is 2, base is 2. So hope this is understandable to all. Now I have revised the things once again. Now we have see what are all the glimpses about why we need to study the number system. Since in everywhere the way of representing a circuit should be in the form of numbers, means their digital electronics come into picture. For analyzing any circuit, we need to follow analog electronics. For design aspects and know the operation, how the circuits are behaving, means we need to use the digital electronics into practice. So following that, there are 4 number systems in practice: binary, decimal, octal, hexadecimal. And based on the standard design protocols, the maximum computational designs are designed to understand only 0 to 1. So as per the standard protocols, if I want to give any default number to a computational system, means then I need to convert that number into either to binary, completely into binary. From any number system, that particular number system should be converted into binary. Then it is processed or computed by the computers, and once again it will be again converted back into original form. For that, we are using so many converters inside the computers for doing our conversion process. But first we need to know how the conversions are possible by using these things. So here we have explained all these things. If I take 125, means if I give it to a system blankly, means it understand only 1. 25 it don't understand, since internal mapping is only designed to understand zeros and ones. So we need to convert this into a binary number. For that, we are having one technique, that is for decimal to binary. What we have to do is, Harden core rule is, from decimal to any number, binary number you want to convert, or decimal to octal we have to convert, or decimal to hexadecimal you need to convert, means simply divide that number by the expected number system. If I want to convert from decimal to binary, means simply divide it by the expected number system is binary 2. Decimal to octal means divided by expected number system is octal, so divided by 8, and similarly 16. And if you want to do reverse operation, means very simple, you need to multiply it with the corresponding number system. For example, decimal to binary, binary to decimal, means what we have to do, multiply that with the corresponding number system 2. Divide that number system by the target number, multiply that number with the target number. That's all, very simple. So we discussed one simple example and do the reverse process also. And also I have given you one exercise for practice, that you can practice, and you can take any number and then do the same conversion process until you get satisfied. So these are all the things what I am planning to cover in this small walkthrough. In the next slides, we will go much deeper into other number systems, how they are able to how they can be converted, or other things we will discuss in detail in the next couple of slides. Okay, thank you very much for understanding. Any doubts, means you can please post me in your comment section. Okay, thank you everyone. Have a nice day.